Okay. So in the previous live, okay. So first of all, welcome to this live session on uh, so 31st 7 2026. Okay. So in the previous live, okay. So we have discussed. So we are discussing the content of week 7. So which is broadly the Bode plot, which is all about frequency response, wherein which in that so we are discussing the Bode plot as well as the Nyquist plot. Okay, so in the previous live, we have seen a problem on Bode plot, and I also have shared two more problems so on Bode plot in the Google Drive of uh, the live sessions notes. Okay, so now in this class, we'll see one problem on a couple of problems on Nyquist plot. Okay, so okay, so Nyquist plot. So basically, when you see in general, we have this P of S as the plant transfer function. Okay, and if we have H of S, which is nothing but the feedback transfer function. Am I correct? Okay. So put together in we call this open loop transfer function. So open loop transfer function as so G of S, H of S. I call open loop transfer function as G of S, H of S. Okay. So basically, this Nyquist plot is all about. Okay. So let me plot here. The Nyquist plot. What we do is okay. So we have this G of S, H of S. Okay. Then we substitute S is equal to J omega. Then we get Z of J omega, H of J omega. Okay. So G of J omega and H of J omega. Sorry. So Nyquist plot is all about plotting uh, the let me varies from 0 to infinity. So that is our intention. And omega varies from 0 to infinity. So we plot all the real values on the x-axis, okay, imaginary values on the y-axis. Is this clear? Any doubt? Okay. Then what we do is so we plot something like this. So I'm drawing this one. So we start at some point which we call that is as v0 plus because we said that we wanted to go from 0 to infinity. So we say that is A. Then we go to B. Okay. So which is infinity plus. Okay. Then we go to uh, we go to C. Okay. Which is infinity minus. Okay. So then we go to D. Okay. So which is 0 minus. Then we come back to A. Okay. So this is the model. Uh, we wanted to plot the Z of J omega, H of J omega, real and imaginary parts by varying the omega from 0 to infinity. To know that behavior, what we do is we go from minus infinity to plus infinity. We plot all the values. Okay. So whatever I said was we start at A with 0 plus, and go to infinity plus at B. Then at B we start, okay. Then we go to C at infinity minus. Then we go to D at 0 minus. Then from 0 minus, then we go to 0 plus. Is this clear? Any doubts? So this transition, we wanted to plot from 0 to infinity, but here on the plot, we go from minus infinity to plus infinity. Basically, we start at 0 plus, come back to 0 minus, covering everything. Okay. And we wanted to see
हाँ वो कोई नहीं पड़ेगी वो पड़ेगी
this particular point. Okay. The real value is
जितना मैंने प्लेस जितना चाहिए
-1. Somebody, can you mute your mic?
Since he's a girl.
Animesh.
It is a girl. It is a girl.
हाँ से करो
Animesh.
Girl है.
Hello.
यार लेकिन बीच में बहुत ज़्यादा
Animesh.
अब जब कोई टॉपिक अच्छा लग रहा था हमको
यार हमको बहुत
Animesh. Hello. Animesh. Can you mute your mic?
अब ये मैम तो हम लोग को पूरा ग्रिल कर दी
Sir, you can mute.
Yeah. That's what I'm trying to. I'm not getting the option. I'm getting like remove from the call. I'm just waiting for. Hello. Yes. Animesh. Okay. So for the moment, I'm.
आईपीएम है ना इसका
Yes. Can you hear my voice now?
Yes,
Can you
sir.
hear my voice, others? Hello. Yes. So is there any doubt on this image? Okay. So now what we do is we consider this point on the real axis. We will consider -1 plus. Since we are considering the point on the real axis, the imaginary part is 0. Okay. So now we have this point and we have this diagram, okay, where we start at A. So go to B and then C and then D to E, C to D and then back to A. Correct? Now finally what we do is, okay, so we will check this equation. N is equal to P minus Z. P minus Z, where P is nothing but, okay, so number of open loop poles. Number of open loop poles, okay, on RHS. Number of open loop poles on the RHS. So Z is nothing but number of closed loop poles on RHS. Okay. So N is nothing but, okay, number of encirclements. Encirclements of -1 plus J0. Is this clear? So finally we will check this and decide the stability. So we say that system is stable or not using this equation. Okay. So basically, what is our requirement to the system become stable? What is our requirement? Can anyone tell me? What is our requirement? Our requirement to be, this has to go to 0. Am I correct? The closed loop system, the number of poles on the RH side should be RH side of the S plane. Right hand side of the S plane should be 0. Am I correct? Okay. So this is the basic structure of the Nyquist plot. Are there any queries? Basically what we do is, okay, let me roughly explain it so that you'll understand it better. So, okay. So you have plant transfer function, you have feedback transfer function. So both put together, we call that is as an open loop transfer function. Okay. That open loop transfer function will find the poles. How many poles are on the right hand side of S plane? Is this clear? Okay. Then we substitute S is equal to j omega. Okay, so you get this d of j omega, h of j omega. Okay, is my voice is audible? My voice is audible. Hello. Yeah.
Yes, sir.
Okay. So what we do is we plot the real part of that z of j omega and imaginary part of the z of j omega on this 2D plane. Okay. So basically we are looking for finding this plot. Okay, when omega varies from 0 to infinity. That is our intention. But here on the Nyquist plot, we check all the values from minus infinity to plus infinity, everything. Okay. So basically, we started like 0 plus, uh, 0 plus to infinity plus, then infinity plus to infinity minus, and back to 0 minus. Okay. Once we plot this, okay, we will check whether this curve whether this curve, whether it is encircling this point or not. Okay, here in this image, it is not encircling. Okay, that encircling means what? This curve, while we go through these arrow marks, okay, the point should be whether it is inside the curve or outside the curve. Here I was showing so the point is outside. But for the problems which we take, we'll see whether the point is inside or not. Okay, so we will check whether the -1 plus j0 point inside or outside, right? So if it is inside, we will check how many times this curve is encircling that point is nothing but n. Okay, then we have this p, which is the open loop transfer function. Okay, so poles, how many poles are on the RHS side? Then finally we will find z. Okay, so our usual requirement is Z should be 0. We don't want any poles to be on the right hand side for the system to be stable. Okay, if Z is non-zero, we say that system is unstable based upon the values of n and p. Is this clear? Any doubts? Any doubts in this? Okay, if there are no doubts, we'll check the example. Okay, if you have any doubts, you can ask. Okay, so let's check the example. Okay, so let's say you have this open loop transfer function as, okay, so s minus 2 by s plus 1 whole square. Okay, so how do I write this one? So s minus 2 by s square plus 2s plus 1. Okay, in this, can you tell me what is the p value? What is the p value? So here p value is 0. Am I correct? Because we have how many open loop poles? We have 2 poles. Okay, what are the 2 poles? -1 and -1. They are on the left hand side. Okay, p is nothing but number of open loop poles on the right hand side. Okay, so now what we do is, so in this substitute s is equal to j omega, so you will get k g of j omega h of j omega equivalent to k. So j omega minus 2 divided by, so j omega square plus 2j omega plus 1. Clear? So this can be written as k j omega minus 2 divided by, so minus j omega plus 2j omega plus 1. Clear? So this is nothing but k multiplied j omega. So minus 2 divided by, so I can write it like 1 minus omega square plus j 2 omega. Am I correct? Okay, right? So now, so this is the one. So I'll find magnitude first. Okay, so let's say magnitude. So magnitude is nothing but z of j omega h of j omega. Am I correct? So what is the magnitude of the numerator? So numerator is root over omega square plus 2. What is the magnitude of the denominator? Root over, so a plus ab, a square plus b square. Okay, 1 plus omega square whole square plus 4 omega square. Clear? Any doubt? Okay. Then phase phi. That is nothing but angle of k, g of j omega, h of j omega. Am I correct? Okay. So what is the angle? So how do you find the angle? Yesterday I told you already. Okay. So the first one here is the j omega minus 2. How does this one looks like? So j omega minus 2. How does this one looks like? Minus 2 plus j omega. Okay. So this is like a plus jb. A is minus 2, b is plus omega. So in which quadrant this point would be existed? Can anyone tell me? Which quadrant? This point would be existed in second quadrant. Am I correct? This is quadrant 2. Am I correct? In second quadrant, okay, real value is negative, imaginary is positive. Okay. In second quadrant, how does the tan looks like? Okay. So how do I write that? So the numerator angle will be tan inverse omega by 2. Is this clear? Okay, numerator. And denominator is tan inverse. So real part divided by imaginary part. Is this clear? Any doubt? Any doubt in this? Any doubt? If you have any doubts, you can ask now. Okay. So if you see this one, how does this looks like? So what is tan 2 theta? Okay, that is nothing but 2 tan theta divided by 1 minus tan square theta. Am I correct? Right? So does this thing look like that? Okay, so how can I write that one now? 1 minus tan inverse omega by 2. Okay. Minus 2 tan inverse omega by 1. That is how I can write. Okay. Is there any doubt in this? Any doubt? Okay. Can you hear my voice? Can you hear my voice? Can you hear me? Any? Yeah. So basically what we did here is, so the given open loop transfer function, okay. So we substituted s is equal to j omega. Then we wrote it like uh, numerator and denominator in terms of a plus jb. Okay. Then we found the magnitude as well as the phase. Okay. These are the this is the step. Clear? Okay. Next, the major part. Okay. So now what I said, I need this image. Okay. I need this image because we have to follow that image. So I'll copy that image here. Okay. I'll reduce the size. Hope you can see this. Okay. So now what I do is I'll go each and every part. I'll go each and every part. Okay. So let us go by part by part. Okay. So first AB. First is AB. Okay. So next is C. Next is BC. Let's say. Okay. So next is CD. So next is DA. These are the 4 parts we have. Okay. So in each part, what we do is we find this table. Okay. So the table is like, okay. So what is omega? We'll have to find 0 plus and infinity plus. Okay. So omega Here, what is it? BC. BC, sorry. Let me draw the table. You'll understand it. Okay. So here, mod M and then 5. Let me directly write it. It's not mod M. It's M only. M and 5. M and 5. So this is M and 5. This is omega M and 5. Okay. So what is BC? BC starting point is so infinity plus infinity minus. Okay. What is CD? Infinity minus and 0 minus. What is DA? 0 minus and 0 plus. Is this clear? Any doubts? These are the omega values. Any doubt in this? We just need to find these values, magnitude and phi for each of this case. Any doubt or query in this? Any doubt or query? Okay, so please let me know. So now, so let me take the let me write the magnitude and the so what is the magnitude we have here? So k root over omega square plus 4 divided by so root over 1 minus omega square so whole square plus 4 omega square. Then what is 5? So 180 minus tan inverse omega by 2. Okay. Minus so 2 tan inverse omega by 1. Correct? Can you hear my voice? Okay. So I'm getting feeling like you're getting everything. Okay. So if you don't understand any of this step, please ask me. Okay. I want finally here I'm trying to draw the waveform similar to this. Okay. By first finding each and every value individually. Okay. So first, let us start with this part. Okay. So let us start with this part. First, and omega is equal to 0 plus. What? Tell me magnitude and phi. What are the values? Can anyone tell me? What is the magnitude when omega is equal to 0? Okay. So this would become 0. So this would become 0. This would become 0. Okay. So here, what do I get? What will I get? So this is also 0. Here we have only 1. What is the value? Can anyone tell me? Is it 2k? Correct? Yes or no? Is it 2k? Okay. Next. So when omega is equal to 0, what is the angle? So angle will be, this will be 0. This is also 0. What is the left? 180. Am I correct? Okay. Similarly, when omega is equal to infinity, so what do we get? The first one will get 0. Okay. The second one, when omega is equal to infinity, okay, this will be 90. Am I correct? This will be 90. Okay. This is also 90. So what do you get finally? Minus 90. Is this correct? Yes or no? Yes or no? Any doubt? Any doubt? Any doubt? Okay. So you just need to find these two values. You just need to find only these two values. The other values are opposite. Other values in the sense you have 0 plus. So obviously 0 minus will be magnitude will not change. The angle will be opposite. Okay. Magnitude will not change. The angle will be opposite. Is it clear? Is it clear? Any doubt? So this is 2K 180. Okay, so if you want, you can check that. Okay. Similarly, infinity plus is 0 minus 90. Infinity minus will be 0 plus 90. Okay. Similarly, this is 0 minus 90, 0 plus 90. Is this clear? These four tables. Any doubt? Any doubt? If you have any doubt, please tell me. If you have any doubt, please tell me. Do you have any doubt? Anyone? Any doubt? No doubts? Okay. So I hope forming these tables is clear. Now what we do is, okay. So what we do now is, so we will consider this original function again. Okay, we will consider the original function again. Okay, so v of j omega h of j omega. Okay, so what is it basically? V j omega minus 2 divided by 1 minus omega square plus 2j omega. Okay, so what I'll do, this one is multiply and divide with 1 minus omega square minus 2j omega divided by 1 minus omega square minus 2j omega. Okay, so how does this changes? Okay, so j omega minus 2 multiplied 1 minus omega square 2j omega. Okay, so here what we get 1 minus omega square whole square plus 2 omega square. Clear? So what is that value is going to be? This is, let us say, minus, sorry, j omega, multiply, I'm multiplying in the numerator, minus, so j omega cube, correct? Minus, okay, 2j square. That means 2 omega cube. Is it correct? Yeah. Is it 2 omega square? Correct? So minus 2 plus 2 omega square. Okay. And then plus 4j omega. Correct? Okay. So divide by 1 minus omega square whole square plus 2 omega square whole square. Okay. So it's not 2 omega square, 2 omega whole square. Is this clear? Any doubt? Okay. So this will be equivalent to what? We can write like minus 2 plus 4 omega square. Okay. Plus j terms minus omega cube plus 5 omega. Am I clear? This is numerator. Okay. So like a plus jb form only. Okay. Denominator, we have that now. Okay. Now, let us take this one. Okay. Real part of g of j omega, h of j omega. What is real part? Make it equal to 0. Okay. We wanted to check real part is 0 means what? We wanted to see what is happening on the imaginary part, imaginary axis. Okay. So what is real part here? Real part is in the numerator minus 2 plus 4 omega square divided by 1 minus omega square whole square plus 2 omega square equal to 0. Is it clear? That is the real part. Okay, so then what does it give us? Okay, it will give us 4 omega square equal to 2. What it gives us? Omega is equal to what? 1 by root 2. Am I correct? So when we take real part is 0. So we are getting omega is equal to 1 by root 2. Okay. Next. Similarly, take imaginary part to 0. Imaginary part to 0. So that is like what is the imaginary part here? uh, minus omega q plus 5 omega. Correct? Am I correct? So divide by 1 minus omega square whole square plus 2 omega whole square equal to 0. Correct? Yes or no? Right? So what does this one gives us? This would gives us, okay. So here two possibilities. Okay, when this will be 0, when this will be 0, okay, first possibility is minus omega cube plus 5 omega equal to 0. The second possibility is 1 minus omega square whole square plus 2 omega square equal to infinity. Am I correct? Okay. From this, what is omega? Omega is equal to root 5. Okay. From this, what is omega? Omega is equal to infinity. Am I correct? Similarly, here also. Okay. When this will be 0, so when omega square whole square plus 2 omega square equal to infinity. Okay, that means what? Omega is equal to infinity. Am I correct? So these are the four possibilities. Correct? So when you make real part is 0, this is first possibility, second possibility, omega values. When you make imaginary part is 0, so omega is root 5 or omega is equal to infinity. Is this clear? This step? Any doubt? Any doubt? Any doubt?
No, sir.
Yeah. So now what we do is we will use these four tables. Okay. So just listen carefully here. We'll use these four tables and drop this the waveform I have shown here in the right hand side. Okay. So I'll copy this. Okay. So let me put it here. Okay. These are the four tables we have. Try to reduce the size. Okay, these are the four tables we have. So now what I do is I'll take so x-axis and y-axis. So in the x-axis, real part of v of j omega, h of j omega. So y-axis, imaginary of v of j omega, h of j omega. Is this clear? Okay. Now, so let's start with the first one. Okay. So carefully read here. Okay. So angles I take in the opposite direction, anti-clockwise. Angles I take anti-clockwise. That means this is 0, okay, plus 90, plus 180, plus 270, plus 360. Is it clear? Okay. So obviously, what are the angles in the clockwise direction? 0. Okay. So clockwise direction, what are the angles? Minus 90. Okay. Minus 180. Okay. What is this one? Minus 270. Okay. Clear? Give me a minute. Okay. Is this clear? Any doubts? Okay. So now you can see here, what is our first point we need to draw? So first AB part. Okay. First AB part. Okay. So omega starts at 0 plus. What is the magnitude and what is the angle? Can anyone tell me? What is the magnitude and what is the angle at with 0 plus? This one. Correct? What is the magnitude here? What is the magnitude? Yes, anyone can respond, please. What is the magnitude? What is the magnitude here? So the magnitude is 2K. Am I correct? Okay. And angle is plus 180. Okay. Where is the angle plus 180? So here you go. This is the angle plus 180. Okay. So 2K is positive. Okay. So 2K is the magnitude. Okay. It does not matter whether it is positive or negative. So what I do is I'll say this is 2K. Okay. That is 2K. Okay. So the wave starts at 180 degrees. It means that it starts like this. Is this clear? This will be my A point. That will be my A point 0 plus. Okay. A point 0 plus. Clear? That will start with a magnitude of 2K. Okay. From 180 it will start. Is this clear? Any doubts? From 180 it will start like this. That is A 0 plus. Okay. Next. So what is B? The B is this. Okay. Infinity plus. What is the value there? Infinity plus. Okay. And what is the angle? What is the angle? Angle is minus 90. It means that A will start at, the AB starts at A with 0 plus with 2K magnitude, 180-degree angle. So 180-degree angle. Okay. And it should end up at where? Minus 90 direction. Okay. And 0 magnitude. Where is minus 90? Okay. So minus 90 is here. To go from 180 to minus 90, what is the path? What is the path? I should go to 90 plus. So first I should reduce one by one. Plus 180 to plus 90, plus 90 to 0 degrees, and then 0 degrees to minus 90. And then magnitude is 0. This will be my B point. B point is infinity plus. Is this clear? Any doubt? So this is how I am going. Is this clear? So here just exactly what we are doing is, so I'm starting my path. I'm starting my path. I'm starting my path from something like this, from 180 onwards. From 180 onwards. Okay. Then I have to go to 90, 0, and at 90, I'm minus 90, I'm going like this. Minus 90, I'm going to 0. So that will be my B in infinity plus. So this is the path. Okay. Is it clear? Next. So this part is over. AB part. Any doubts? That is AB part. Okay. Next. BC part. Okay. So BC part also see, you can see BC part is B is same. Okay. It has to start at where? It has to start at uh, it has to start here. Infinity plus. Okay. So 0 minus 90. 0 minus 90 is this one only. This point only. It is starting there. Okay. And so, and where it has to end, C point. C point is what? This is A. Let me bring that diagram also. This is the diagram what we made. You can also see this diagram. Okay. So what is the C point? C point starts at minus infinity and ending at C point. Sorry, BC point starts at infinity plus, ending at infinity minus. Okay, at infinity minus, what we have? 0 and 90. 0 is same thing again. 90 is what? This angle, the vertical angle, this one. So it means that the point will be there only. Okay, so that is C infinity minus. Is this clear? Is this clear? Okay, so the important part, compare this image with this image. Okay, here AB is a straight line. Am I correct? But here, what is AB in the real image? It is a big curve. Okay, here BC is a big curve. Okay, what is BC here in the real image? That is just this point. Is this clear? Is this clear? Okay, so that part is done. Next, yeah. Okay, next, CD. Okay, CD, what we do? So we start at infinity minus, that is C point. That is point C. Okay, so same point, this point only. Okay, and we end up at 2K minus 180. 2K minus 180. So again, minus 180 from, you are at what? You are at 90 degrees. Correct? So how do you go to minus 180? So you start at plus 90. Okay, you start at plus 90. First go to 0. Go to 0 and then go to minus 90 and then go to minus 180. Clear? That's why 2K minus 180. Is this clear? This is how we go. Is this clear?
Sir, where is the C point, D point?
So C and B are same origin only.
Sir, D.
Sorry? D point is this. Now we came to this point. That is D point. Because C is this. Okay. So C goes like this. Okay. And this is the D. Okay. So D, let me put it. This is 0 plus. And this is D, 0 minus. Clear? So now you can see DA point. DA point is exactly 2K minus 180, 2K plus 180. Is this clear? Is this clear?
Yes, sir.
Yeah. So now you can observe this closely. Okay. So AB point is a straight line in the model image. Okay. Here, that is this one. Sorry, that is this one. Correct? It goes like this. Am I correct? Okay. BC point is, sorry, BC point is this off circle. Okay. Here, this is just a simple point. Okay. Then CD point. CD point again a straight line. But here, this is again a big curve, something like this. This curve. Is this clear? Clear?
Yes, sir.
Yeah. If you have any doubts, you can ask me.
Sir, I couldn't be able to understand the CD point.
CD. So
Yes,
you
sir.
can see this. This is C. Okay. What is C here? Infinity minus. When omega is equal to infinity minus, what is the magnitude? Zero.
0.
What is the angle?
90.
That is the starting point. Magnitude is 0 means here. Okay.
Yes.
Okay. What is 90? 90 is this angle. So in this direction it starts. Okay. With 0 magnitude, 90-degree angle, it is starting point. Okay.
But yes.
Then D is what? 2K with minus 180. Correct?
Yes.
So now you have to, this is the starting, this is the ending. You have to end at 2K minus 180. This is 2K, this is minus 180. So you have to end up at this point. From this point to this point, you cannot go like this. Correct? Because you are at angle plus 180. Plus 180 to minus 180, how do you come? So you have to go to 0, 0 angle, and then you have to come to minus 90, and then you have to come to minus 180. Is this clear now?
Yes.
That's how it goes. Okay, so this is the Nyquist plot. Okay, but we use this model plot to draw the real plot. Okay, now, okay, so are there any queries? If you have any queries, you can tell me.
Awesome.
If you have any queries, please let me know. Okay, now, so previous here, we have calculated two things. When real part is 0 and imaginary part is 0. Okay, when real part is 0, we don't consider this omega is equal to infinities. Okay, so we'll consider this omega is equal to 1 by root 2. Okay, so when we consider omega is equal to 1 by root 2, okay, what is the magnitude? It is this one when omega is equal to 1 by root 2. Can anyone tell me what is the magnitude? You'll get magnitude as root 2k. Okay. Similarly, when omega is equal to root 5, that's what we get now, root 5 rather. Okay. Root 5. So what is the magnitude? What is the magnitude here we'll get? We'll get m is equal to k by 2. Okay. These are the two things we are getting. Okay. When real part is 0, okay, so we are getting magnitude as root 2k. Real part 0 means what? Real part 0 means what? Basically, where this point will be on. It will be on y-axis. Am I correct?
Y-axis.
So y-axis, what is the value? Root 2k. Okay. Uh, omega value is what? 1 by root 2. Correct? That is this point. Okay. So omega is equal to 1 by root 2. So magnitude is root 2k. This one. Is this clear? Similarly, the other case, when omega is root 5k, root 5. What is the value? K by 2. Okay, so that will be this point. Omega is equal to root 5. Okay, so magnitude is K by 2. Okay, any doubts? Any doubt here? Any doubt? Okay, those are the two expressions. Okay, now consider other case also. Okay, so take omega is equal to 0. What will you get? Magnitude. When you take omega is equal to 0, we'll get 2k. Am I correct?
Yes.
Right? So 2k is what? This one. Correct? Okay, now let us see this point. Okay, that point is -1 plus J0. -1 plus J0. Okay, so here basically what is the magnitude? Okay, magnitude is 2k is less than 1 if you consider only the magnitudes. Okay, so what is the k value? K value is 1 by 2, correct? K value is 1 by 2. Now, so now come to the final stage. Okay, so we wanted to check the stability. We wanted to check the stability. Okay, so what is our equation? N is equal to P minus Z, correct? So what is P here? Tell me. P is nothing but what?
Poles.
The number of open loop poles on the right hand side. Okay, from the given problem, how many poles we have? 2 poles, -1 and -1. They are on the left hand side, correct? So that means P is equivalent to 0, correct? P is 0. Now, if you see this, the entire path, okay, so the path started here, it went like this, okay, it went like this, it went like this, and it came to till this point, okay, in the clockwise direction, okay. It in this entire path, it is encircling this point once. Am I correct? So n will be equivalent to 1. Okay. Now what is the z value from this? Z is what? -1. Correct? Yes or no?
Yes.
So z is non-zero value. Hence, the system is unstable. Okay. So we need to get z is nothing but the number of closed loop poles on the right hand side of RHS plane. Okay. Here z should be 0 for the system to be stable. Okay. But here we are getting that is non-zero value. So hence it is unstable. Is this clear? Any doubts you have? You can ask me. You can ask me any doubts.
So 2K is positive. How do you mark it left side?
Sorry.
2K is
This
positive.
is the condition. This is the condition. That is magnitude, no? That is magnitude. Magnitude, and it has to start at plus 180. You see this? That's the key point. It has to start at plus 180. So that's why it is 2K. If it is 2K, 0, we should take on the right hand side. Correct?
So, but the magnitude itself is positive.
Magnitude is positive, yes. We are comparing only the magnitudes. Okay.
Should at the left side it should be negative, right?
No, I'm talking about magnitude, mod value.
Okay.
Yeah. Okay. So hope you got the clarity on how to draw the Nyquist plot and decide the stability. Okay. So let me quickly take one more problem on the Bode plot. So yesterday we discussed about, so again, I'll give you some problems on Nyquist plot. In the same way, you can solve them. Okay. So this is one more important problem in the Bode plot. Okay. So yesterday, if a transfer function is given, so drawing the Bode plot we discussed. Okay. Now what if a Bode plot is given to you? Okay, what if a Bode plot is given? So how to get the transfer function? Okay, so this is the one, sorry. So quickly I'll explain it. 1, 2, 4, so 8. So this is 24, 36. Okay, so let me try that. Okay, so hope you can see. So this is dB. Okay, so this is minus 20 dB per decade. Okay, this is 0 dB per decade, and this is plus 20 dB per decade, and this is 0 dB per decade, minus 20 dB per decade. Okay, and this is minus 40 dB per decade. Okay, so now this is the transfer function given to you. Okay, sorry, Bode plot given to you. Okay, so Bode plot of z of j omega h of j omega. This is given to you. Okay, now the question is, what is its transfer function? Find transfer function. Okay, so we have to, just by looking at the this image, we have to draw the transfer function. We have to write down the transfer function. Okay, so first what we need to do is, given this image, okay, given this Bode plot, first to find out what are the slope changes. Okay, here let us say here we have this minus 20 starting. Okay, so minus 20 to 0. What is the slope change here from minus 20 to 0? How much is slope change you are getting? Plus 20. Am I correct? Yes or no? For minus 20, if you add plus 20 only, it will become 0. Then from 0 to plus 20, what is the slope change? Again, that is plus 20. Am I correct? Okay. Then from plus 20 to 0, what is the slope change? Minus 20. Am I correct? Then from 0 to minus 20, again minus 20. Am I correct? Again, from minus 20 to minus 40, what is the slope change? Minus 20. Is this clear? Any
Yes, sir.
doubt? Right? So now based upon this slope change, we decide whether we are adding a pole or 0. Okay. So when there is a here, since this is the 0, okay, so first value, so we will add a pole here. So one pole at origin. Okay, next if you see here we are adding a plus 20 slope. Okay, so plus 20 slope means we add a 0. We add a 0 with omega c, corner frequency as 2. Why 2? This 2, corner frequency. Is this clear? Okay. Similarly, here, okay, we are adding another plus 20. So that is also 1, 0. Okay, what is the corner frequency here? Omega c is 4. Is this clear? That is 4. Why 4? This 4. Okay, next here. So we are adding minus 20. So obviously it will be one pole.
Oh,
Okay, that will be corner frequency is 8. Okay, here one pole. What is the corner frequency? 24. Okay, here one pole. What is the corner frequency? 36. Is this clear? So based upon the slope change, we decide how many, what is the, whether we add the pole or zero. Okay. So one more thing I forgot. Okay. So this is the extended like this. Right. This is already given in the problem. No. Sorry. This is this means the slope line, if you extend, it will reach at 8. Okay. Is this clear? Okay.
Yes,
Now,
sir.
we'll write the transfer function T of S. So we generally take the gain. Okay. So we'll have numerator as well as denominator. You see how many poles we are adding, how many zeros we are adding. Okay. How many poles? 2 poles. One pair and another pair. Okay. So generally, what is the format we take? So we take the format as 1 plus ST, where T is the time period, which is nothing but 1 by corner frequency. Okay. Which is nothing but 1 plus S1 by omega C. Correct? Okay, so now we'll add like this. 1 plus first 0. What is it? S multiplied 1 by 2. Am I correct? This one. So first one is pole. That you can directly add it. Okay. So this is 0. Next 0. This one. What is it? 1 plus S multiplied 1 by 4. Correct? Next. This one. So 1 plus S multiplied 1 by 8. Okay. So 1 plus S multiplied by 24. 1 plus S multiplied by 36. Is this clear? Is this clear? Any doubts? Any doubt?
No, sir.
Yeah. So now almost you got your transfer function. Only thing is that finding that gain K. Okay. So the gain K, what we do is,
So
okay.
one more police is
Yeah.
there at origin.
Yeah. One more pole. So that is 0. That is 0. I mean, 0 frequency.
So
Almost at 0.
if we do like
Ah.
it's going to be infinity, right? 1 by omega c.
No, not like that. Not like that. So the here the value is 1. So the almost 0. Okay. But you are getting a slope change to minus 20. Okay. Slope change to minus 20. That's why you're adding a pole. Okay. So now what you do is you have this x-axis value is 1. Y-axis value you don't know. Let us call that is as y. Okay. And this line, as you see that slope line, it is extended till 8. You can say that is x-axis is 8, y-axis is 0. And make here, these are not simple x and y-axis. Okay. So these are logarithmic scales. Okay. How do I write that? What is the slope of that line? Slope of that line is minus 20. Correct. How do I write that? Y minus y2 minus y1 by x2 minus x1. What is x1, x2? They are logarithmic values. Log 1 by 8. It means that log 1 minus log 8, which is log 1 by 8. Okay. So if you do these calculations, you will get 18 y. Okay. So y is 18. Now you will be calculating x as like k as like this, that y is equivalent to gain. Okay. So 20 log k. Okay. Plus slope. Okay. Slope change log omega. by 1. Okay, so please go and see previous live why I wrote it like this. Okay, to calculate the next value, we have to calculate the k is the gain at 0. Okay, gain at 0 plus slope change multiplied by the two values, which will give you the next value, that is nothing but y. Okay, now you substitute the values. So 20 log k plus slope is minus 20. Okay, so log, so this will be 1. Okay, omega is 1 here, log 1. So log 1 is 0. Okay, so from here you will calculate k as, so approximately 7.94. Okay, so finally your T of S is nothing but close to approximately equal to 8. Okay, 1 plus S by 2, 1 plus S by 4 divided by S multiplied 1 plus S by 8, 1 plus S by 24, 1 plus S by 36. Okay. So this is your transfer function. Okay, so if you want, you can take this transfer function. Okay, so see the previous live and draw the Border plot. You should get this. Okay, then you will understand these two steps. Okay, somewhere in the while drawing the Border plot for this transfer function, you will also draw this. You will also write in the middle this one for the k value. Okay, so that is for finding the next something like y is equal to x plus c. So previous value plus slope change multiplied by the current value. Okay, so this is how you will do from write the transfer function from the if Border plot is given. Okay, so previous slide we have seen given transfer function drawing the Border plot. This is given Border plot drawing typing the transfer function. Okay, so I'm hoping these things are clear. I'll share some more problems on Nyquist plot in the drive. So you can do the practice and you can ask us any queries you might have. Okay. So thank you. We'll stop here. Thank you.
Thank you, sir.
Thank you.